Okay, here comes the proof for the sum of a GP, and yes, sorry guys, you've got to learn it off by heart. Okay, the sum is the first term, which is A, plus the second term, which is AR, plus the third term, which is AR squared, plus the fourth term, which is AR cubed, and I'm getting bored now, so I'm going to go straight for the last term, which, as we know, is the nth term, which is AR to the n minus 1. Now, what I did when I did the proof of an AP is I reversed it. I'm going to do something completely different for the sum of a GP, and what I'm going to do is I'm going to times everything through by R. So I'm going to get R lots of Sn equals, okay, this times R is AR, this times R is actually AR squared, this times R is AR cubed, this times R is AR to the 4, plus dot dot dot. Now, I've got to times this by R. Can we just come down here a minute and have a little look? AR to the n minus 1. AR to the n minus 1 times R to the 1. Now what happens when we times things? We add their indices. So actually that gives me AR to the n. So in here is coming plus AR to the n. Okay, so now what I'm going to do is I'm going to take a big fat line and I'm going to call the first one number 1 and I'm going to call the second one number 2 and I'm actually going to do number 1 subtract number 2. Do you remember in the AP one we added them, in the GP one we subtract? So I'm going to get Sn minus R lots of Sn equals. Now, if we put a big fat line around the second one, we've got to do the whole of the first, so that's the whole of this bit, and then we've got to subtract the whole of this bit. So watch what's going to happen. This AR subtract this AR will cancel. AR squared subtract AR squared disappears. AR cubed subtract AR cubed disappears. And of course there'd be an AR to the 4 there, subtracting with the AR to 4. Now this bit here will subtract with this one. I haven't actually put him in, but if you think about it, the one back from AR to the n will be AR to the n minus 1. So actually that subtracts as well. So let's have a think what we're left with. We'll be left with this, which is A, minus, so there's the minus, this, which is AR to the n. Okay, let's have now a little think. I'm going to take this side and factorise out a sum. So Sn, so this is going 1 minus R. Okay, and then in this side I'm going to factorise out an A. So we're getting 1 minus R to the n. And then I'm going to go, the sum is A bracket 1 minus R to the n over, and I'm going to divide by this, 1 minus R. And that is the proof of the sum of a GP. And I'm afraid you just need to learn it off by heart.